guys. And I'm like, no, you got that wrong.
See you, like, during the race.
Good.
Before, I never saw you.
I about got
like,
ran
all
over.
The time.
Really? Were you on the
Okay,
track?
so right at the beginning where you go by the trees, I
Yeah,
was
he was
there
right
off
there.
to the side of the trees, but all the girls went the way you're supposed to. The boys were trying to pass each other, and they like about ran straight into me. Like, because, you know, there's not a photographer there when you're running the practice course. So then I was at... You totally saw me by the gate.
I saw
Yeah.
you. Also, you.
I was after the gate when the girls were running. I was after that corner, but then I realized there was a better spot. And then I was near the finish line. Girls, a lot of girls almost ran into me. So then I was not in the same place during the boys. I hid somewhere that I was safe. So I will upload those pictures, and you guys can pick whatever goes in the yearbook.
Oh,
Um,
all ugly.
Yeah.
Like any of them.
Okay, then we'll get a group picture or one of those like before. I realized as I drove away, I should have had all you guys get together and just had like a Phoenix. Here's our cross country runners.
You know what was terrible? Our bus driver never came. We had to push in on one bus, and the entire ride was just
I'm sorry.
Oh yeah, we only have one bus, and there's like some seats that no one sits on.
All right, because you guys are going to camp tomorrow, all we're doing today is finishing up this lesson, and that's it. I'm taking some time to do work and we'll turn in practice if we can. No, I don't have them uploaded. They're still on the camera in my car because I'm going to volleyball tonight, so I just left it in my car.
Oh my gosh, are you going to do again on McCourt?
It's at Kilburn High School. It's actually Volley for the Cure, so it's a cancer research fundraiser.
Wait.
So, should be. It's Cards versus Wolves. Both
Wow.
I'm gonna be honest.
Do you
What?
always go to the Cards versus Wolves?
I try
Because you
to
can
if
do
I
both?
can make it.
I mean,
If I can
the
make
third
it.
team is pretty legit. I mean, the eighth grade team, they need help.
All right,
It's
so
not that they're bad, it's that they need help.
we had this situation yesterday with the one-on-one shooting. I asked you guys to start to keep thinking about this and try to figure out, do we agree with what we got or disagree? And what does that even mean? So if we go back to yesterday, I'm going to clone this so I don't have to keep jumping screens. So we had 60% free throw average each shot. Right? We built this, but at the end of class we were like, nah, do we agree?
I do not agree.
You do not? Okay, let's keep this conversation going.
Okay, so, like I was saying before, so out of all the outcomes, the greatest possible outcome is that she'll get 0 points. But if you just look at the first shot, she has a greater chance of getting points than she doesn't. So,
No, wait, the greatest possible outcome is she gets 0 points.
well, if you look at
I
all,
thought that was only 40%.
Yeah.
if you look at all the, like, if you
No,
look
like,
at,
here, let me explain. Okay, so if you get, if it's between 2, 1, and 0, 0 is highest. Like, if you're not looking at them, like, together. If they're, like, separate things, then 0 is
But
highest.
2's a better chance than 1.
No, but,
So-
0 is a better chance than 2, so 0.
But 0 is a lesser chance than points.
But we're not looking at points, we're looking at, we're not looking
I
at, like,
am.
that's not what the question is.
No, but we are. We're talking about expected value.
This is the
Expected
three-
value
this is the-
of points.
What is the most likely of the 3 possible outcomes?
Well, yeah, but when I narrow it down to 2, there's points or no points.
It's
Right?
the point.
Then we get more specific.
Yeah.
Now, I'm not saying this is right or wrong. I'm just pushing a side of the conversation. When I look at this, there's a 40% chance of no points. I get that. That's pretty big. But there's a 60% chance of getting points.
Exactly.
And then from that, and actually it's not a 36%, it's a 36% chance out of everything. But if we just looked at the chance of getting points, and we broke that up into 1.2 points, 2 points is pretty, like, it's stronger than 1 point. Or because she's a pretty good shooter. So I don't know. What is, that 0.96, if it's the answer, what is that? That's the expected value outcome of what?
That she's even gonna shoot.
Well, but what do you mean? So that's
I don't
points,
know.
right? That'd be 0.96 points. Is that for one shot?
I'm confused about.
Wait, why did you multiply all the percents together?
Why did you add them all together?
We have to divide them by
Wait, you
Those are great
multiplied
questions.
2472, but you multiplied a 0 instead of
You didn't
40?
multiply.
32.
Oh, that's add? Oh, I thought that. Oh, yeah, you're right.
Why did you add them together?
But still, you
get 72?
30.
What? Where did you? What?
Where did we get these numbers from
I don't
yesterday?
know.
It's not my numbers. You guys got these numbers.
You wrote it down.
Ain't my problem.
So I don't
What's 72?
well, because it's combining one and because so with the zero value there is the first shot, but
Can I go back in time for that?
Oh, let's go back.
Hello. You quiet down. So if we go back to yesterday, gotta have sound effects. Which, actually, if we go back to here, remember all this multiplication type stuff?
Yeah.
Remember that we did, because we're gonna need to do that again. This. Our expected outcome came out to be 264. What was that? That was the expected outcome of.
The money you should
like
spend.
if we got money, we'd have an expected outcome of 2.
If you had to pay for it, the expected outcome would be like 2, whatever it was. So if you had to pay for it, you'd want it to be under.
But outcome of what?
The chance that.
What?
Oh, for this one, it'd be the predicted outcome.
If you got money, it's the predicted outcome.
How did you get money?
By
Spinning.
By spinning
Twice and getting the same number.
twice. This is the expected outcome after 2 events. Like, you didn't pay for both, right? You paid and you did 2 things. But this 2-way table is the expected outcome of after 2 things happened. Right? So, shot 1, shot 2. This, if this is our expected value, that's after 2 shots have been made. So if you're looking at that as 0.96 compared to 1, it's not. That's 0.96 compared to a potential 2 points. Remember, the best outcome here is 2 points possible. If we're still struggling with this,
Wait, so it's like the money only. If you shoot twice, how many points you're expected to get?
Why is it 17 instead of
on your graph paper. Nah.
You see, that's what happened to us.
Yeah, you just unplug it and plug it back in.
Well, we didn't have that.
That's what you have to do. On your graph paper.
I guess I know now.
Oh, wait, we're
Shot 1.
right?
Oh, I love these things.
Right? Let's just look at a different model. If the model we were using doesn't make sense, change it.
I think it makes sense now.
If she misses, what happens?
It's done.
She goes back to the bench and gets sad.
Yeah.
If she makes it,
She keeps going.
she shoots again.
She could miss or
She
make
gets
it.
the starter position.
Or not.
That's not done. Actually. What is this result? 2 points. What is this result?
1.
And 0. What is our chance we get to here?
It.
I feel like we're playing Plinko. We drop a thing. 0.36, right?
Oh.
Yeah.
I think I remember.
Oh my God.
Our chance here. Well, I should use green for the first one. That would have been better instead of blue. But okay, I go green here.
Is that how you got the 0.96?
That's how we got it. Oh,
That is? Yeah.
There's a 36% chance of 2 points. And a 24% chance of 1 point and a 40% chance of no points, making.
So there's a higher.
Stop doing
There's
that.
still a higher chance that she get no points than 1 point.
That's not what we're asking.
Oh, I get it. Okay, I
Plus
get it.
0. And there's a 9.
And this is not necessarily after 2 shots. This is when she goes up to the line. Bounce, bounce, shoot. What's the expected result? Yeah, it's more likely she doesn't get points because obviously we're below 1, right? We're less than 1. Now, it's still probable she gets some, but when we compare no points to 2 points, what you're saying is true. It's more likely she gets no points than she gets 2 points. That's why we're closer to 0 than we are to 2. But is there a chance she gets points? Yeah. And when we do the expected calculation, 0.96. But that's when she steps up, she might have only taken 1 shot and missed and gets 0 points. But she might make the first and then miss, gets 1 point, or make the first and make the second, gets 2 points. So the 2-point expected outcome comes out to 0.72, the 1 point, 0.24, and the no points, 0. That's how we got our 0.96, and that is actually the expected outcome.
I think I get it.
Does this make sense? I know it's a weird one because first off, the 1-on-1 basketball shot is weird because it's not like you take 2 shots for sure. Like you might. That's what makes it tough. All right, let's try another one. See if we can maybe do better at this one. We've made a number cube, and we've decided that if Janie rolls a positive number, she'll gain that number of points. However, if she rolls a negative number, she'll lose that many points. I don't like that they're using dice because we're talking about 1 right here. So this is what we're talking about. 1 roll of this dice, right? It's a die. 1 number, or they could say number cube because it has numbers on it. It is just a number cube. But all right, so what again makes a game fair? When we started talking about expected outcome, we talked about fair.
When there's an equal chance for.
What do you mean equal chance?
When there's an equal chance for any possibility to happen.
Kind of, sure. But I mean, the number cube has an equal chance of each side coming up. Does that mean
chance of winning?
If the expected value is like 0.
The expected value is 0. So if I take a normal die and I make a game that is I win on even, you win on odds, it's fair. But if I make a game of you win on 1, I win the rest of the time. The die is fair. Each side is fair. That game's not fair.
So the expected outcome is.
Expected value or expected outcome is
So
0.
this number cube would be not fair because there's more chances to gain points than lose points?
That's not necessarily true.
Okay.
We have to figure out the expected value.
Wait, hold on.
Of course we do.
If the expected outcome is less than 0, then there's a higher chance of losing. And if it's greater than 0, then there's a higher chance.
In this game, yes, because negative is loss. She loses points. So how do we do expected value? That probability with that outcome. Right? So we know each, well, wait a minute. We can put some things together here.
Oh boy.
2, 2, and 2. What's the expected value of that? Or yeah, well, okay. Well, not quite. What? Sorry, I should ask this differently. Thank you, Athena. Half, right? What's the probability? I asked the wrong question. So, half chance of getting 2. Remember, expected value, probability, outcome, add them up. What's the expected value, or how do we get to the expected value? 1/3 of -4.
Why does no one ever want to put them with the same denominator?
7/6 plus a negative 8/6.
Yeah.
1 and 1/6. 7/6.
Plus negative.
Make this a denominator of 6, 8/6.
So then it would be negative 1/6.
So then our expected outcome is negative 1/6.
So there's a higher chance for you to lose.
Higher chance of losing.
Don't play the game. Don't gamble.
I mean, not a higher chance of losing, but a chance. It's not worth the risk.
Yeah, higher chance of losing points. Yeah.
It's more likely to actually like win points though.
Here's the hard part.
Win gamble into. Change only one side of the dice from the expected value.
You shouldn't need it, but the max amount of time you have is 5.
I love how
Decide as a class.
one thing David takes away from that is good gambling tips.
I mean, they are, if you think about it.
How can we choose what we change to make this fair or an expected value of 0?
Okay, I have an idea.
Wait,
Talk with each other.
first can I say my idea? Okay, so if you're to roll it 6 times, then you get one of each of the outcomes. So if you just add each of the outcomes,
Oh, I see
0.
that. It's a meme.
We can only change one side though.
Yeah, so if you change like one of the negative flows to
I just thought that. I just thought
Just
that.
change the one
I
to
added
2.
all
Quit talking to
I
me.
added all the outcomes to the first one together. And then I divided by 6 there and it just came up like that. So you just have to find the mean of it. That's the
So like add them all up and divide.
No, but we're trying to find it.
No, wait. Actually, like hold on. So shouldn't we just try to get like the odd numbers to get their fraction to be equal?
Hey, what if we listen to one idea and try it instead of everyone just pitching ideas and nobody trying anyway?
Yeah, so let's try changing the 1 to a 2.
So then that would be.
Which one to which
That would
two?
be 2. There are 4 1s.
Well, that one there was 1 1.
Changing the 1 to a 2?
So that would be
Great.
2/3 times 2.
Yeah,
And
that's
then
right. That's right.
that works.
Because it adds up to 0.
Yeah, that'd be 4
Then it'd
thirds plus
divided by
negative
negative
4 thirds, which is 0.
That's right.
Can you go through your process again? Okay, sure.
No, we'll go through it again. I'm gonna clone this and clear it.
You have to add them all to 0 because when you divide it by the mean, it'll still be 0.
That's what I said.
Yeah.
Yeah, but he hadn't realized it yet. It doesn't matter if you say it before someone's ready to realize it. This is what I've learned as a teacher. It doesn't matter if you already said something. It really doesn't. So you said change this to a 2, which now means we have 1, 2, 3, 4 sixths. I'll just leave it in nice, denominator. Chance of 2. And let's keep it in sixths, a 2/6
Or you could do 2/3 and 1/3.
chance of negative 4. Or yeah, okay, thirds could work too. We get 8 sixths plus negative 8 sixths.
Which equals 0. And that's okay.
Now, here's the thing. This game is fair, but it looks like it's weighted towards the person with the positive.
There's more outcome.
Right?
But
so
if
this
you get a negative outcome,
So-
you lose more points.
this is how you make your gambling booth. Right?
I bet you
Because
tricked them.
this is where the game is fair. You can say it's a fair game. We did the math. It's right here. But it looks like they have a better chance to win.
Yeah.
There you go.
You just give them a bunch of small points, and then when they lose everything.
Only what we do is we change the
Yeah,
1 to a 0.
it's
So
back
it's
up
weighted
from-
Now,
towards us.
remember,
How did he do
that-
I
Hold
wasn't-
on. I got to clarify something. That's only true because we're talking about gaining and losing points. We're not saying when positive comes up, you just win and the game is over.
No.
Because then positive really does have an advantage.
Yeah.
What we're saying is the point outcome when played long term will balance out.
Wait, but my question is, how did you come to that conclusion? How did you get?
The
How
probability
change the
of,
one to
so let's,
two?
seriously, let's step by step, make sure you understand this. We take the probability of the outcome times the outcome.
that?
So that is how we got 4/6 times 2 to equal 8/6 as the positive, like, that is long term. Every roll has 8/6 positive, and 2/6 chance of a -4, which when we compute that is every roll has a -8/6.
I mean, I was asking like how he knew to change a 1 to a 2. Was it like guess and check?
No, because if you
It
add
would just
them,
be
One person at a time. Athena. Since you. Yeah.
because we gotta make it like the same number.
Yeah.
So the easiest one to do is just change the 1 to a 2.
Okay,
Then
great.
2 plus 2, 2, 4, 4.
so here. So if you add them all together, the 2 plus 2, all of them equal 0 together. But if you had it 1, then it'd be -1. So then it'd show that it was weighted.
Okay, great. I get it.
So if you add them all together and it equals 0.
Sweet. Spin it right. If region A is 7 degrees,
Oh.
what's our expected value?
This one you just have to.
Somebody can take this.
Why not? Because I got nothing better to do. So.
Nothing better to do in math than to do math.
Yeah.
360 divided by 7.
So.
It's that.
No.
What is 360 divided by
51.428.
Why are you doing 360 divided by
I'm
7?
trying to see like
7
the
divided by
fraction.
360.
Oh, okay. 0.0.
So.
There's no F and D. How do you do like
Whoa,
fraction
whoa,
to
whoa.
decimal?
Leanne.
No, how do you do fraction to decimal? That's
He said there's no F and D. Yeah, it's like he was using the F word. No, it's there's no F to D. There's no fraction to decimal button on the 83s.
You never expect Mr.
there
Hudson
is-
to say that.
There is.
What?
If you go to math, there's your fraction decimal conversion. So I'm going to show that. Yeah, so what I was trying to make a silly joke off Liang looking for the fraction decimal conversion button. If you have an 83, where's my 83?
Why are you being weird?
There's no fraction decimal button. But if you hit math, which is right here, the first two options are convert it to fraction, convert it to decimal. They have an arrow. That's your fraction to
That's how
decimal
you
to
do
decimal
decimals
fraction.
in this calculator.
There you go.
Like, this is the first time I've seen a fraction on this.
Always ask. If there's something you want to know, ask.
How do you do like okay, I have another
Sammy's
question.
up here trying to do stuff, and you're just like.
How do you do like heroes?
I don't get
No, wait. Why did you do 360 divided by 7?
Okay.
Because that's the
Fine,
problem.
I'll erase it.
Getting that.
360 divided by 7?
No, I mean 7 by 7.
Ah, 7 divided by 360.
Yeah, so it's you can't.
Now we could just use the
And
fraction.
then,
Yeah.
so,
That would be
that
like
would be 353.
degree.
Yeah, that's good subtraction.
Wow,
Now, what are we going to do with those probabilities?
we're going to turn them into fractions.
Well, okay, yeah, but that's what I meant by the probabilities. They got to be a fraction or something.
We're gonna make it. Wait.
What do we do after we have that fraction? What do we do after we have the fraction?
You do something with the fraction. That's
Find the thing.
We multiply with it, right? So we're going to take our 7 over 360. I would not make it a decimal because it will be probably kind of gross.
Times 355 will be 60.
Times 355. What do we multiply that by?
353.
Wait, what?
What are we multiplying these 7 over 360
Oh
by?
my
Two.
goodness.
No, it's 100.
100. So that's really 700 over 360. Right? Like,
Wait.
it will be. Yeah, just put your 100 in there. We'll do the math here in a second. Now, if you want to come back to your papers, you can write it down. You can. I'll scribe up here if you want.
I kind of like doing this.
Okay. Now, you might want to shift. So you have a little bit more room.
Oh,
Bring
yeah,
that
that
over
might
here.
be.
Look at that Hudson match.
All right, so then for this region, we got to write down that probability.
So it's like 353 over 360.
What?
Put a plus sign. And you might have to change your size. Oh, there you go.
353. No, should we do 353 over 360 times 2? And then we can find our expected value.
Times 2?
And can someone figure that out? Because I don't have a calculator on me.
It's on it.
1400. 1406.
Oh wow. Wow, that came out to be a not ugly number.
No, but divided by we should have done
Over 360.
Yeah.
Oh, I lied.
So that's good enough. And then I can just, what?
But what's the?
Is that the expected value of this string?
Why is that the expected value? 'Cause, I mean, the fact that you guys are asking me makes me ask you, why does that make sense to be the expected value?
Because math said so.
Because it's in between 100 and 2.
Yeah. There's no negative up here. There's no 0 up here. You're either going to get 2 or more than 2.
Yeah.
And if, in this case, you get more than 2, you get a lot more than 2. Like, a lot.
But there's a higher chance that you get.
But there's a much higher chance you get the 2.
So that's why the expected value is.
So we're going to be closer to 2. But that 100 has a lot of pull away. Right? So if it was 2 versus like 5, that number would be really close to 2. Because the 5 has a tiny sliver.
Yeah.
So even though that 5, like, and that they told you at 7 degrees, because that's not to scale.
No.
Right? That is definitely not to scale.
Yeah.
It will be way smaller than that.
More like,
Okay.
But if it lands there, you get 100.
Yeah.
Right? So think about games like Wheel of Fortune or Price is Right with giant wheel games. No, that's perfect. You're done. People have thought about this. Right? People have computed the expected value. When they put those numbers on the wheels or the prices or the things, the prizes, the bankrupts, I don't know how much game shows you guys watch, they thought it through.
The reason why this is
so many-
the reason why this is close to 2 because there's a higher chance to get 2, but it could be closer to 2, but it's not because 100 is so big.
Yeah.
Okay.
So if this was 50, this
be
would
like-
probably barely be 3. It'd probably actually be 2 something still.
Okay, cool.
Yeah. That's why the 100 had a decent amount of pull, even though it was a tiny sliver. What? Oh, it's not my fault that you came to the board to write.
oh, well.
Actually, it is because I handed you the pen.
Yeah.
Oh,
Okay, I'm good.
The last thing we would think about is how do we do this process backwards? So when we talk about those game shows and people having to design things, we want the expected value of each of these spinners to come out to be 3. So right now, what math do we set up? And obviously A, they start us kind of easy and we get more difficult.
So wait,
What do we know right now?
the X is 90 degrees, and the other one would be 270.
Yeah, but it's 3/4 of 1.
Use fractions. 3/4.
Okay.
Or, I mean, we could do 90 over 360, but you probably don't want to.
and that is going to be the expected value.
Now you math.
Oh wait, but
What
then
else
we
should I
say
write?
equal 3.
Ooh, equals 3.
Julio.
He was a
Multiply
rapper way
everything
back
by
when.
4.
Yeah, Coolio.
Oh.
You've never heard of Coolio?
No.
That makes me sad. What does 3 turn into if we put it over a 4? What's 3 turn into? 12 fourths, right? Sorry, what improper fraction more so is mean? 3 over 1.
Multiply everything by 4 to get rid of.
Oh, we don't even have to do that.
Okay, then you subtract.
No, we don't even have to do that. What should
X
X be
is
here?
6.
6.
Come on,
We
because
already
you're
have
all
common
4, so
denominators.
we don't need a denominator.
Make your life easy, Liang. I agree. Everything you just said we could do, it would work. So I never want you to feel like I'm saying you're wrong, but we don't need to. Right? We have the common denominators. 6 plus X is 12. Now, the first thing Liang said, I did do, so I shouldn't have said no, but I just did it in my head. If we have common denominators, you only look at the numerators.
Yeah.
When we have the common denominators, we only care about the numerators. So do that for B and C real quick. You have 3 minutes. I bet you can do it.
Oh.
What?
You have 3 minutes. I bet you can do it.
Great.
I believe in you.
I
I
did 360. So what is that fraction? Oh, that's a 6.
What? 6?
Yeah, each
Yeah.
small ones are 6. Is 6. So 2/3 x, 2/3 times x.
Yeah.
Plus, negative 3. I mean, wait. No,
What?
not negative 3. 1/6 times negative 3.
And then 1/6 plus
Plus
1/6
basically just 1/6.
times 1/6, which equals 3. Oh wait, can we change it 2/3 to like 4/6? So then it's just
So then you multiply all the numbers because
negative 3/6.
What's the, equals 3 no wonder. They all equal 3.
What probability did you give X?
What?
What probability did you give X?
4/6.
Yeah, don't make it 2/3. Keep that common denominator. 4/6.
So x has to be 3. Yeah, because that'd be 12 plus 3.
No, that can't.
What it
Hold up.
Wait a minute.
I'm pretty sure x would be 5.
So we have to make.
I don't know.
Make
I
the
got
board.
x equals 5.
As we get quicker with this, we'll start to recognize patterns and strategies. Our value gets multiplied by our probability. And you guys started by saying these are both 1/6. So we could really write down we have -3/6 plus 1/6 plus
Okay. 4, 6, x.
4x 6,
Oh, wait.
Yeah.
right?
So wouldn't x
Equals 3.
So you could just say that. Okay, and so 3. Okay, so 18.
That's 2.
Is that 18/6? 18/6. So -3 plus 1 plus 4x equals 18. So we just add 3. 5. X equals 5. Like what
Yes.
Sophia said, exactly.
Slower.
Except with a lot more words.
Yeah.
I got x equals
5.
And you guys are awesome. You can have one chicken.
Yeah.
I'm always looking for some sort of calculator.
No, Danny.
Why do I want to go put my book away?